thank you for coming. I think it's really important for us to support these events. As you know, Susan Jaglal is taking the initiative to make sure that our academic environment is top rate. I think that particularly our students deserve a stronger academic environment with more journalism and more seminars and more rounds. This is all part of it. It's an opportunity not only to come and listen, it's also an opportunity to contribute. And I note in the last week that Angela Colantonio has organized with her team a whole series of talks on traumatic brain injury, and I noticed also that Katrina Steele has organized a week of celebrations of swallowing difficulties and solving them. So the spirit has started. Thank you for coming. Tilak leads what used to be called the technology team and is now called the home and community team. Probably the home and community environment team, that's yet to be decided. And the reason was that technology is something that pervades at least half of the efforts in this organization, whereas, as you'll become rapidly aware, the work that Tilak leads is particularly on the environment. And you may remember that the reason that we call research here IDAPT is not just the labs down the bottom of the building. IDAPT is the whole of research at Toronto Rehab. That's its identity. And it was called IDAPT when we originally got the money, which, by the way, came to renovate Lyndhurst. It came to create the sleep labs. It came to collect, everyone thinks of it as simulators, but it was the whole place. The reason was a play on the word adapt. The idea that rehabilitation is a process of adapting people to their environment by giving them a wheelchair or an artificial limb or supervision or whatever, and adapting the environment to the person by giving the environment a ramp or some sensors or something. And it was the adaptation from both directions that was originally the idea behind the word IDAPT. It was, the I came because it was Apple time, it was intelligent, individual and catchy. Everyone's eventually got onto that bandwagon, so it has less impact. But anyway, that's where IDAPT came from, and that's also where the French Réadaptation comes from as well. So there's some bilingual context there. So that's the importance of the work that Tilak does. And over to you. We're being recorded. We're on the so that people in other sites can see, but also so that this series and all the other events that we're doing are on YouTube channel, and In the Know has given out the links to that. Thanks.
Great. Thanks for that introduction, Jeff, and thanks for all of you for being here today. Really excited to be able to share some of the work that our team has been up to. I have the privilege of getting to talk about this work, but it's really a lot of people behind it all, and I'll try to note who it is that's responsible for the work as we go through this. I want to start by sharing what I think is probably my most profound lesson that I've learned in adulthood. And it came from this book. It was Karasek and Theorel. In 1990, they released the first issue of this book, edition of this book, and they talked about the demand control model. And what they talked about is in work, if you go to a job, what types of jobs are considered healthy and which ones are considered unhealthy. What they figured out is that you could plot jobs on this two-dimensional grid. I'm simplifying quite a bit. They have quite a few other factors that they looked at, but one simple way to look at it is to plot the job on this two-dimensional grid, looking at how much demand a job puts on you, which we traditionally think of as how much stress, and think of as kind of the negative aspect of any job, is how much stress you're under. But they said that alone doesn't tell you whether a job is healthy or unhealthy. You have to look at how much control someone has in their job, how much autonomy they have. And if someone has the tools and the resources and the autonomy to deal with the challenges they face, they will have a healthy job. So people like surgeons or professional athletes are under a lot of stress and under a lot of demands and run into problems all the time. But they're given the tools and they have the knowledge and the autonomy to solve those problems regularly. And so they actually are very healthy. And health, they looked at things like cardiovascular disease, they looked at high blood pressure, drug use, depression, a lot of really interesting things. They looked at cortisol levels in the blood, which can and link that to hardening of the arteries and things, and showed that actually people that are in this area are fairly healthy. They call them active jobs. As opposed to people if you have high demand jobs and low control over your job, you will find if you don't have the tools or the knowledge or the freedom to solve the problems that you're faced with, you will have an unhealthy job and have issues with substance abuse and depression, and all sorts of negative things come with that. So someone like an assembly line worker who is told to build widgets and doesn't have any say on how they do that job and runs into problems and talks to their supervisor and says, I think I have a better way to do this, and the supervisor says, just go and do your job the way I told you to. Those are unhealthy jobs. There happen to be other jobs on this side as well. We won't get into that right now. But the point is that in work, you can tell a lot about happiness and health in life based on these characteristics. And I think, and I haven't been able to find any studies that talk about life in general outside of work, but I think it applies outside of work. I think it applies to the rest of our lives. If we have the tools and the knowledge and the freedom to solve problems, and we feel like we're in control of our situation, we will be happier and healthier. So if we think about older adults as we age, think about the types of challenges we tend to run into. So we end up having mobility challenges and other health challenges as we get older. We tend to get more frequent challenges like that. The question we have to ask is, do we provide older adults the tools they need to solve the challenges they're faced with? And I think, unfortunately, the answer to that question is no right now, and we'll go through some examples of challenges that we don't address particularly well. And what our team tries to do is find better solutions, give older adults better tools to deal with the challenges so that they feel like they have more control in their lives. So one of the scenarios we think about with older adults, what we know is that everyone wants to grow old in their own homes. And so if you think about this couple, this scenario where an older adult has just come back from the hospital after an illness or an injury, their life is going to change dramatically suddenly. They have to, let's say after this gentleman maybe has had a stroke, now his wife is suddenly in charge of getting him up out of bed, getting him into the bathroom, getting him dressed, toileted, bathed, lifting, moving, depending on how much mobility he has. She has to make sure he doesn't fall and hurt himself. We have to make sure she doesn't hurt herself lifting him up out of bed into his wheelchair. If there's an injury for either of them, they lose a lot of independence. One or both of them end up in a nursing home. We end up with dramatic reductions in the quality of their lives as a result of some of those things. So those types of things right now are what we're trying to address, those types of challenges. Being able to live successfully, age successfully at home also means being able to get outside, and thinking about the types of equipment that we give people, things like walkers and canes and even footwear when someone's outdoors. Thinking about how well these things work, I think it's easy to see that they don't work particularly well, and so our team is looking at ways of improving some of these tools that we give people. So our objective is to give older adults and their caregivers better tools to age successfully in their own homes, and we'll look at sort of 3 different areas. We'll look at preventing falls and encouraging mobility, we'll look at preventing injuries in caregivers, and preventing the spread of infection. The first point, we'll start with that one. So we know we want to prevent a fall, but one way of preventing falls is just by keeping people in bed all the time. But doing that has some negative repercussions as well. So we have to find a way to keep people active. We know from the last Research Around's talk, Paul O's talk, he highlighted the need to keep people as active as possible. So how do we prevent falls yet encourage people to stay active, even in the winter, when we know a lot of people with disabilities right now stop going outside? And that period of inactivity can lead to some negative health effects that could be as profound as the ones linked to falling. If you fall and have to spend some time healing, you spend some time in bed, being laid up in bed, losing cardiovascular health, muscular health, those same things can come from not being active in the first place. So it's a balance of those two things that we need to encourage. This is a video of Elm and University. Watch this person as he or she tries to walk across and see the fall there. So what are the reasons for that fall? I like to think of them in sort of three groups. One is it's something about the environment. It could be that there's snow in the environment. It could be that the intersection design itself could have led to that fall. It could be something to do with the individual themselves. They might have had a balance deficit, a balance problem that led to that fall. Or it could be something, the interaction between the person and their environment, so their footwear in this case, that could have led to that fall. So let's see how we're going to talk about two of those. We'll leave out the intersection design, but we can talk later about, if you want, we can talk about how curb cuts themselves, the way we design intersections, the physical design of that may not be designed particularly well for our environment. But we'll look at balance control and footwear. Let's talk about bathrooms and falls in this video. Why did that fall happen? It could be the tub is too slippery. So we'll look at what we're doing about falls in bathrooms as well. Start with footwear. How do you know if you face a day like this, when we get a couple of these every year, when there's ice around in and around our homes, how do you know that how well your footwear will perform in this environment? Are you sure that your footwear is going to keep you upright, or will it perform like these boots? So there's a very slight ramp here that this participant is trying to walk over, and you can see that she's having trouble making it across. The footwear themselves, if you looked at them, I doubt that you would be able to say that they would perform so poorly. The challenge is by looking at a pair of footwear, and like we all do when we go to buy a pair of footwear, we turn them over, we look at the soles, and we try to say, oh, this looks like it's going to grip that ice really well. It's got knobby treads. Unfortunately, you can't tell by looking at a pair of footwear how well it's going to work. You have to find a way to test it. And so we'll talk about how we do that here. The tire industry has figured this out. They have objective tests and labeling systems for their tires. So when you go to buy winter tires, you look for a little symbol on the side that tells you that these tires have met a certain level of performance, and so they will perform well under certain conditions. Why can't we have that on footwear? Well, that's actually what we're trying to do. Here, I'll demonstrate our footwear testing protocol with an example of these 4 shoes, and I'll let you choose which shoe you might have picked if you were looking for one in the store. And I'll show you how we do this testing. And this is work that Yue and Sharon and Ben have been working on, along with Jeff, in Winter Lab. So we do a lot of our tests in these simulators downstairs in the basement. For those of you who may not have seen this, there's a motion base that we can place different pods onto and bolt them on. And this base allows us to move these pods in different ways. For footwear testing, what we're doing is creating a slope. And so we have people, in this case we have Jeff wearing a pair of boots, walking back and forth on an ice surface. So at the back, this is inside Winter Lab now. You can see Jeff is harnessed and, on a harness system, so he's perfectly safe, walking back and forth, and we can progressively tilt this slab higher and higher. And in this case, he's walking on a dry ice surface, and we can determine what is the steepest angle that those shoes are able to climb. In this case, about 7 degrees is where he starts to slip backwards. Right? We can also create a wet ice surface. So we can put some water on that ice, and with the same pair of shoes, you can see it's much slipperier now for this pair of footwear. So already at a 1 or 2 degree incline, you can see there's quite a bit of slipping happening there. And we can also, we can also do testing with snow. I'll show you that in a second. You can see the pile of snow in the background. But let's look at what a different boot performs on that same wet ice environment. And this time we're going to start at 5 degrees. So this is now boot 2. And you can see we've already outdone boot 1 on wet ice. Remember, boot 1 only got to 7 degrees on dry ice, and we have now a pair of footwear that can do wet ice at 19 or 20 degrees. So pretty phenomenal differences between footwear. This, and the other condition that we test is to place some snow on top of the surface of the ice. So you can actually see the pile of snow is actually behind Jeff, and what we've done here is just brushed a little bit of that snow onto the ice surface, and this is on a dry ice surface, and you can see all of a sudden the shoe that was climbing a 20-degree incline can now only do about a 5 or 6 degree incline. So all of a sudden we see a difference in the performance. So you can see the challenge that we're faced with. We have to figure out, of those 3 conditions, what shoes can do the best. We don't want to give someone a shoe that can do one condition really well, but the slightest bit of snow on that surface would cause them to slip and fall. These are the results that we get, though. In this case, this is the dry ice condition. You can see for the 4 shoes how well the different shoes did. And hopefully you see some surprises in that. I know when I ask for a show of hands who would have picked which ones, most people pick boot N, and they tell me it's because there's a little bit of yellow on it. So think about that, and think about how the superficial nature of the marketing of this thing can make you choose something, and think about what that means for practical, for the public and what they need to know to be able to choose the best footwear. So what we're hoping is this test is going to become the new standard for footwear, and we're working with a number of companies, Mark's Work Warehouse, Columbia, Vibram, a number of them who want us to test ranges of their footwear and work with them to label it so that the public will have this information when they're in the stores. Boot J is a prototype boot. It's a prototype material that's on here. It's not actually available on the market. But we were so intrigued by this. I mean, this material blew us away. And we were so intrigued that we got involved with the mechanical engineering materials people, Dr. Hani Naguib at Mechanical Engineering, and was his PhD student, now a postdoc working here, took a look at this material, put it under a microscope, and found that there were little glass fibers that were embedded inside this rubber matrix. And the little glass fibers actually acted like little spikes, and it actually performed better on wet ice than on dry ice, which is interesting. The challenge with this material and why we don't see it on shoes yet is because it actually wears out fairly quickly. So the glass is a fairly soft material. If you walk on something like concrete, you'll wear it out. So right now, Rez is working with us to try to figure out if we can make our own version of this material with tougher materials that may not wear out. But the potential is pretty neat. And so what Yua and Sharon and Ben are doing is going through with Mark's a lot of their footwear, and with footwear that they're getting volunteers to bring in, we're trying to compile basically a gigantic list of all the footwear that we can find that's commonly used to rate it, and so that people have, that we can publish on the internet so that people can have an objective way of choosing their footwear. We still need to figure out how we're going to deal with the different performance of the 3 different materials. So that's the challenge that we have to deal with at this point. Let's move to poor balance control. So this is, so what can you do if someone has a neurological problem that causes them to fall or to have poor balance? What can you do to help them? Well, indoors, Emily and Vicky have been working on developing a product, and the name keeps changing on us, but it used to be called the Move Easy Kit, and the kit is made up of a bunch of these poles. So there's vertical poles that you don't need to screw in or bolt to anything. You tighten a nut and it expands between the ceiling and the floor and holds itself in place very rigidly. And we also have a set of horizontal pieces that you can clip on wherever you need them. So you can quickly give someone who might have a balance problem a really good handhold to get them from one place in the house to another. And you can get them moving independently, which is really important in terms of making sure people have as much mobility and independent mobility as they need. And so, for instance, in this case, Vicky's illustrated getting someone from the bedroom to the bathroom. Getting on and off a toilet is often a big challenge, or getting in and out of the tub can be a point where you get people slipping a lot. This is a video of my mom, actually, who is starting to have some arthritis issues in her knees, and sometimes if you don't have a balance problem, but you just have trouble getting on and off the toilet, or issues getting in and out of the tub, simply putting one of these poles can make a huge difference to someone's ability to be independent in their own homes. And she loves this pole. So there's this paradox that we're talking about. You want people to be as active as possible. You want to get exercise, but people who are at risk of falls, obviously, there's a serious danger of having people exercise and be active. And so how do we deal with that challenge? This is a video that was taken by Steve Rabinovich's group at FSU. Well, Avril's group has been doing some great work with balance training. So someone who has a balance deficit, the way you can improve their balance the best is to actually push them around and have them lose their balance over and over again, and have them regain their balance over and over again, and have them react to someone pushing them. So they do this sort of stuff in the clinic here. Now, Sean and Vicky are going to work together to see if we might be able to use some of these poles, the Move Easy pole kit, to harness. So the key part to that is having someone safely lose their balance and regain their balance. So could we use a series of these poles to harness someone in other environments, at home ideally? So that's something that Sean's going to look at for his master's. Bathrooms. So Emily and Allison built this lab, we call it Bath Lab, with sort of see-through walls. And they have a tub and a toilet and a vanity inside there. And they looked at a whole bunch of different activities that happen with people moving in and out of the tub and moving on and off the toilet to see where the risk of falls are, and how we can prevent, if there is a slip, how we can prevent someone from hurting themselves by putting a grab bar in the right spot. So you saw the video of someone slipping in the tub. One of the things that we know we can do is make tubs less slippery. So that's one of the goals, is to work with ASTM, which is the American Society of Testing and Measurement, or in Materials, I think, to actually, they're the ones that define the slip resistance of a tub. And they agree that there's an increasing belief that the standard that's used is sort of archaic and tubs are just too slippery, so we need to come up with a better way of defining the slip resistance of tubs. One of our ideas might be to actually put a tub on our tilting platform and actually have people walk back and forth on that platform and see if we can keep them, and see when they actually start to slip, to define a more realistic test compared to what they do now, which is with sort of a mechanical pendulum tester, which doesn't, it doesn't mimic a person walking on these materials at all. So Emily and Allison will try to make that change happen. They're going to try to make grab bars, working with the building code people to get grab bars required in bathrooms, and figure out where the optimal locations are for grab bars when you're stepping in and out of the tub, to make it as safe as possible. So for instance here, this plays. So for instance, if someone's stepping into the tub, is the best place for a grab bar in front of them, beside them? You have to, when you're framing the house, you have to know where that 2x4 goes inside the house so that the grab bar can be installed in the right place. Allison, so that's with the building code committee that Allison sits on. She recently had a really big win with the building code committee to change stair dimensions in the building code. So the minimum, so here you can see her test setup, where she can actually slide these staircases to make the stairs longer or shorter. What this is data that wasn't collected by her, but she built on some of these findings. Stairs that are 8 inches long, which is what the current building code or the past building code would say, the number of injuries you get when the stair is 8 inches long, which is the distance where you put your feet. Going from 8 inches to 10 inches, there's a 3 or 4 times as many injuries on an 8-inch stair as on a 10-inch stair. So having a smaller stair means that your foot can slip off as you're going down much easier. And so what she was able to do was to get the building code now in 2015. Very soon this will become part of the National Building Code, that the minimum length of stairs in Canada should be 10 inches. And we know that that should reduce the risk of falls on these minimum length stairs by a factor of 3 or 4. In 5 years, once this has been accepted and put into building code for a while, we're expecting that that will result in about 4,400 less injuries in Canada every year, and about saving 13 deaths every year, starting in about 2020. So Vicky is also the next step, working with Allison. The next step is to figure out what is the best shape and size and position for handrails when you're moving, for handrails to prevent serious injuries if you do have a slip-on stairs. And so she does studies in the stairs lab where she has a handrail, a person walking next to the handrail, the lab suddenly jolts and the person has to react. They lose their balance and they have to react to that. And from doing that type of testing, she can determine what the optimal range of handrail shape, sizes, and positions will be. The other thing with bathrooms, getting on and off the toilet. So this is an image of a bathroom that we actually visited as a home visit for an older adult who used a walker. And the challenge that this person had was they weren't able to use their walker while trying to get onto the toilet. There wasn't enough space between the toilet and the tub to actually get inside there. And so usually he would have to wait for his support worker to come and take him to the bathroom. So one of the things that we're considering is someone who needs a walker. Could we develop an adapter for a toilet that would actually allow you to shift the position of the toilet in the bathroom, and now allowing the person to access the toilet much easier? And that's a project that Emily, Pam, Adam, 2 Adams, and Steve are looking at. We call it Toy Locator because it'll actually let you shift the position of the toilet. It also raises the toilet up. There's a product right now that Jeff worked on a long time ago that was called Toilevator, which would raise the height of the toilet. So really this is an adaptation of that product to see if we can use it to also shift the position of the toilet. The other reason we may want to move the toilet is to help the caregiver. Most bathrooms are not built for 2 people to be working together inside there, but sometimes it can help to have a bit more space around the toilet where the caregiver who's lifting someone on and off the toilet to get them in closer around to the side. And so Emily's been doing a lot of work looking at this in home lab upstairs, in the home lab bathroom, bringing in real personal support workers and patient actors to see what are the most challenging activities, where are the risks of falls, where are the risks of injuries happening in all these different activities if you have an older adult, maybe with a balance problem, that you're caring for in that space. Where do you, and looking at questions like, where do you put a bath bench? Which end of the tub should that bath bench be? How do you instruct someone? What's the safest way really to bathe someone or toilet them? Should they be sitting? Should they be standing? How do they get in and out of the tub? All those kinds of questions. Because we know that caregivers, so this is data from institutions with nursing homes and hospitals, experience the highest rates of injuries of any occupation. Right? So think about mining. So if you know someone that you don't want to have a back injury, if you have a son or a daughter or something, tell them to go into mining. You see 3 times as many injuries in caregivers in institutions than you do in mining. And that's not even in the home environment, right? Here at least usually you have 2 people working together and you have lift equipment involved. What we're talking about at home in the pictures and the people that Emily is dealing with is people working alone in confined spaces. There's probably clutter everywhere. They don't have any equipment. So we don't have any good data on this, but we expect that the problems are even worse in the home environment. So thinking about that from a healthy work perspective, it is the client's home, and so there are certain limitations on what we can do there, but it's also the personal support worker who goes in, it's their workplace as well. So it's an interesting balance, finding ways of making that job safer. So we're doing that in a sort of a two-pronged way. Again, we're trying to deal with the individual as well as with the environment. With the individual, we're trying to see if we can find better ways of training and getting them to understand where the challenges are coming from. So trying to explain why the risk of back injuries is what it is and how it can be prevented. Trying to get people to understand that even though the spine can support 750 pounds, that's where we start to see these little micro tears in our intervertebral discs, you really shouldn't be lifting any more than 35 pounds, right? Why is there this big gap? Well, it's because of the way the back actually balances the load. It's sort of like this teeter-totter where even though you're lifting a fairly light load out at some distance, your spine and the discs in your spine have to support not only that weight, but the weight of your erector spinae muscles contracting like crazy to balance your upper body mass and the thing you're lifting, and all of that weight ends up on your spine. And so when you add that all up together, you see that you shouldn't really be lifting more than about 35 pounds if you don't want to get a back injury. And it explains why people talk about, you should be lifting with the load close to your body, right? There's a practical what leads to that practical recommendation, letting people hopefully understand that a little bit better. But then also understanding that it's tough to do those types of things, to keep the load close to you when you're doing any kind of lifting activities. And so, trying to find, what we've been doing is trying to find different ways of getting people hands-on kind of experiential feedback. So we've developed this app called SafeBack, where you can take a picture of one of the caregivers in a certain pose. We can pose a little model on the screen, and we can calculate what the load on the spine is, and we can compare that to a safe limit. From that, you could then start playing around and say, okay, if you try to lift a little bit, keep your back a little bit straighter, if you could raise the bed, watch how much your load in your spine would change. So we're trying to see if tools like that might be useful for coaching and training caregivers. We're also trying to see if some videos, so we've created this website with a series of videos that have some testimonials from nurses who've had back injuries and the impact that's had on their lives, as well as sort of direction, sort of like this, and why it's important to, what you hear is keep your back straight. Why do you need to keep your back straight? Well, actually what you're trying to do is you're trying to keep the curve in your lower back, right? Keeping that curve in your lower back means that you keep the facet joints in your lower back connected, so all of the bones are in contact down here, so the load that's on your spine, instead of being concentrated on the disc, if you arch your back the other way, all the load ends up balanced on the discs alone. Instead of that, what you want to maintain is this curve so that you can share the load across your spine. Trying to get those messages in a persuasive format that allow caregivers to understand what these directions that they might be told what they mean is one of the things we're trying to do. But at the same time, again, we recognize that there may be cases where these jobs, it's really hard to do these jobs while keep thinking about that, right? It's one thing to hear that and read about it, but then very different when you're trying to do something in the field, washing someone's feet, for instance. So we've developed a wearable tool as a sort of a prompting device. The idea is you have two little sensors that are mounted on the person's upper back and lower back, and as the person moves, if they move too far in one direction, you get a little vibration. It's from a smartphone or something in your pocket. So you can see that someone, if they bend too far and lose that curve in their spine, you would get a vibration, versus if you kept your back straighter, you wouldn't. And that's something that Tara and Justin, Mark and Felipe have been working on, and we're excited to really test that out and see if that can be used as a training device and a coaching device. It's more like training someone the way an athlete is trained, right? You don't just tell them, okay, I want you to keep your arms straight when you're throwing the ball. Like a coach will watch the person and then give them feedback, and over through repetition, you slowly start to change behavior. And that's the idea here. If we can get people repetitive feedback over and over and over, maybe we start to change behavior. And then, is this something that you wear for a week or a couple of weeks and then take away? Or is it something that you continue to use in your job or anything like that? We also have to understand or find a way to help people understand that there are some biomechanical limitations to most jobs. So we know there's a lot of biomechanics that's been done on manual lifting, so lifting without any equipment, lifting someone from a bed into a wheelchair or vice versa. You're well above what's considered a safe limit when you're transferring someone. So we know we need to be using some sort of technology to be when you're doing these activities. But even if you use technology, there are still activities like getting a sling under the person before you can use the lifts that may be causing some of the injuries that we're seeing. So some of our work has shown that even just rolling someone, whether you have 1 or 2 caregivers doing these rolls, with only a 200-pound patient, you're already starting to hit that risky kind of level of effort or load in the spine based on how far you have to bend and the way you have to roll someone. So we're also trying to think about, well, what happens once you scale up to larger people? We know that people are going to be getting hurt just from putting slings under people, so we've been developing tools to try to address that problem.
SlingSerter is an easy-to-use tool that effortlessly inflates a series of lifting straps under the patient, greatly reducing the risk for injury. Once the straps are placed under the patient, they can be attached to an overhead lift, which gently raises the patient a few inches, making it easy to insert the sling. Having the patient elevated also gives healthcare workers the opportunity to insert a bedpan, change sheets, or reposition the patient as needed. SlingSerter is just as easy to remove. Just pull the exposed end out. It's designed with the patient in mind. As you pull, SlingSerter turns inside out, so there isn't any friction or discomfort from the straps for the patient.
So that device is something that Emily King, it was an undergraduate thesis project. She's now a PhD student with us, and we're hoping that this will be out on the market very soon. But it's a product that we think could change the way lifting is done and really add to that for home care workers or other caregivers, make it much safer to lift and move people. The other thing we're trying to do is do more biomechanics of these tasks, because so far all the work that we've done is in clinical environments. Very little is known about the way people lift and move in the home environment. And many of you may know about the Microsoft Kinect sensor. So this is a little video game sensor. I think it costs $200 or $300, the new version. Using it, it's sort of like a little 3-dimensional camcorder, rather than the $100,000 motion capture system that we would need to use with the existing methods that we use for for measuring in the lab. We want to be able to do these measurements in the field, and so Ali and Roa have been working on methods of basically turning this video game sensor into a biomechanics measurement tool so that we can take this into people's homes and actually understand how some of these activities, what the real loads are when you're doing these activities. And preventing the spread of infection. So we know that about 1 in 9 people in Canada who go in for a hospital stay right now, contract a bug that they didn't have when they went in. It leads to, I think, 10,000 deaths every year. It's a huge cost to the healthcare system, and we need a better way to, and really we think half of those issues could be taken away if people wash their hands the way we know people should be. So the alcohol gel dispensers, really you should be activating an alcohol gel dispenser before you go in or out of a patient room. But unfortunately, the healthcare is such a hectic job. It's if you did wash your hands the number of times you're supposed to, you'd spend about an hour of your shift. So there's about 100 opportunities to wash your hands over the course of a typical shift. If it takes you 30 seconds to get to one of those gel dispensers, wash your hands, you'd be spending 50 minutes a day just washing your hands. So it's easy to forget. It's not that people are not doing it because they're lazy or anything like that. The problem is that it's something that needs prompting. Again, similar to the lifting idea. It's when you're in the thick of it and trying to move quickly and you have one thing that you need to do that you're thinking about, you need something else to prompt you from time to time. And so the idea is that the healthcare workers would be wearing a badge that looks like this, that talks to sensors that are attached to the ceiling, both inside and outside a room. And those sensors are tracking whether the person, as they move into the patient zone, has already washed their hands. If they have, it stays silent. If they haven't, it will give a gentle vibration just to remind the person that you need to wash your hands. And what it does is when you go over and activate one of the gel dispensers, it records the fact that you did so and when you did so. So you can keep track of all that, and then it can present statistics on the unit level if needed. And so we've tested this system now at a 50-bed facility and more than doubled the hand hygiene rates in that facility and maintained it at that level. But that was through a research project, so we know that people that consented to be part of such a study liked it and used it. But the next step really is to test it with people as part of their regular work, and that's now happening. It's being installed in a number of units around, including at this hospital, and we'll see how well it catches on. And this is the type of data that the system, which is called the Personal Infection Protection System, this is the kind of data you can get and look at how it's changing over a given reporting period, the rates that you have as you're entering, exiting, and how much people are wearing the device to begin with. Just as an aside, the alternative is things like this. So hospitals, because of the costs and the problems with people getting bugs and people suing, more so in the United States where things seem to be more litigious, the people are installing closed-circuit camera systems that watch to see if people are washing their hands. So there's actually cameras in a number of units now that are viewed, I think in India, it says in this article. I think people observed so it's a real-time feed that's observed by workers in India watching to make sure that people are washing their hands as they're moving in and out of hospital rooms. So that's the alternative that we're looking at. So I'll just finish by giving a brief sort of summary of sort of the process that we go through as we approach these problems and look at the different areas. Then I haven't been able to cover all the project areas that we're working on. I've tried to just give a little window into what we're doing. Our team the goal of our team is to bring clinicians and technical experts together, so we have a really diverse team, and we think about what problems older adults have at home. We often go visit people in their homes to try to understand those problems better. We come back and think about how we can address the problem that we've identified, and then we start to evaluate it using simulation. So we've talked about a few of the simulators that we've used, Winter Lab, Stair Lab, Street Lab is one that's sort of like the holodeck, sort of for you that are Star Trek fans. It's a surround a screen that goes a large amount of the way around you, so that you can walk on a treadmill and experience what it might be like to walk downtown, for instance, downtown Toronto. Those are 3 pods that then get swapped on and off of our motion platform. We're building a 4th. Very soon we'll have one that's called Driver Lab, that is basically a car that has a windshield, a real windshield. It's a real car that you'll be able to test older adults' driving abilities inside. And it's something that allows you to spray real water onto the windshield, and so that you have to turn the windshield wipers on when you get in. And at night when you're driving, real lights, this is what this thing on the side that you see here is, it creates headlights, so real headlights shining into your eyes, so that you actually have to deal with and to try to basically recreate what are the most challenging situations when you're driving. So driving at night, driving in bad weather, to try to objectively determine if older adults are capable of driving in those conditions. Because we think that older adults, your car becomes more and more important to you as you get older, and suddenly taking someone's driver's license away, it can be devastating to them. And we think there probably could be a graduated delicensing system, so that maybe someone at a certain point is no longer allowed to drive at night or on highways, but during the day they should be able to go to the grocery stores and get to their doctor's appointments and visit with friends, so that they can stay tied into their communities. And that's really, that's a major goal of our team, is finding ways to keep people active and engaged in their communities. Upstairs on the 12th floor, Care Lab and Home Lab are two other simulators. So a lot of the infection control type work we're doing is in Care Lab. Home Lab is where I mentioned Emily was doing her bathroom injury prevention work. So we do that evaluation through simulators, and usually what we find, if it's a product that we're developing, we often have gotten it wrong, and so we have to kind of go back to the drawing board and consider new concept ideas. Once we think we've got it right, we take the idea and put it into the home, into the real world, whatever that is, and test it there. Hopefully we've got it right. Sometimes it needs to come back again, back around. But eventually we are convinced that the product is ready. And the thing that differentiates us from other university kind of lab environments is that instead of waiting for this point to get our idea involved with commercial partners or other stakeholders, that's been going on all along. So commercial partners and policymakers are deeply involved with all the work that we're doing here, so that once we get to the point where we think we've got something that's ready to go out, it's a far easier take-up at the end. And along with the development, we're making sure that we're getting documentation carefully done, so that the regulatory approval phase is relatively easy to get through. Sometimes our ideas are forward-thinking enough that commercial partners aren't willing to take them up. They're too big a risk, or the markets haven't been defined well enough for a lot of the products that we come up with. And so sometimes we launch startup companies and get things out into the market that way. But that's kind of the process that we go through to try to get our products and ideas out. And I just want to end by saying that disability affects all of us, and all of us will either have a disability that we deal with of our own, or care for someone who has a disability. And actually, just last week, this gentleman, who's a really neat guy, he's a retired music teacher. I'm sure everyone has someone like this in their family. A retired music teacher built a pipe organ in his garage. He was showing this off for us last summer. About a month ago, he fell, and last week we just heard that he passed away, and it was from the consequences of a fall. 2 older adults living at home, and it was just something that really hit home for me, that these things that we work on here are very important for all of us to think about, because it will affect our lives. So that's it. Thanks very much. This is our webpage if you want to have a look at some of the other projects that I haven't been able to talk about. That's my email address. Feel free to email. I'll also be here at the end. I guess we have some time for questions.
We certainly do.
Yeah.
I have a couple of questions.
Sure.
One is about, my first question is about the footwear base that you were talking about, the sole, if there have been implications for wheelchair wheels.
Tires?
Tires.
Interesting.
If there's been thought put into that. And my second question was about the toilet locator.
Yes.
Is the plumbing affected? Is the efficiency of the plumbing affected if you move the toilet into that, the angulation change?
So the first question, the footwear, we haven't really thought about tires, wheelchair tires, though scooter tires, we have started doing some testing with scooters, We've actually seen this shift. People that use wheeled mobility devices, a lot more people are choosing scooters rather than wheelchairs. And so we have a program right now ongoing with Winterlab where we put scooters inside and drive them up hills to try to understand what traction they have and what we need to do, and sort of a similar testing program for scooters to make sure that they can do what people will need them to do outside in snow and ice. And so those findings will likely get applied, I would imagine could be extended to wheelchairs eventually, yeah.
I was thinking about manual wheelchairs to maintain the mobility of the person for as long as possible in their physical activity.
Yeah, so that's something we haven't done, but would fit well with what we're trying to do. Absolutely.
We actually have.
Have we done that? I didn't know that. Oh, there you go.
We're doing it. It's a little-known project, but it's been going in the background for quite a while. We're building a wheelchair simulator. We're building one copy for Edmonton and one copy for here. And we've been doing studies in Italy at the moment, at the University of Padua, looking at a model of the tire, which turns out to be the most important element in its construction. And it is intended eventually that we will be able to study doing wheelies in a wheelchair simulator that will actually allow that eventually. It's several years away yet. And that we'll be able to study doing wheelies on ice, but that's a long way away yet. So you have to wait a bit longer, but we've been doing that.
Yeah. And the second question was, the toy locator. Yeah, right. So, so that is part of what we're going to try to understand. So the first, we haven't yet built a prototype of this. We've sort of envisioned that this thing could exist, and so we need to build a prototype and see exactly what you're asking, how far can we move it, there needs to be some slope in the soil pipe, but what is that slope that we need in that? Yeah, exactly. Yeah, other questions?
First of all, it was a great talk. I really enjoyed what you're doing, even though I know part of it, still it was amazing. A comment at the conference recently, and they were all talking about how all the treatments of the patients should go toward falling into 4 Ps, or supporting 4 different Ps, which is to personalize treatment, predict, prevent, and participate the patient. And what was amazing for me was that you're sort of doing all of those. So you're personalizing the treatment, you're predicting and preventing the injury, and you're trying to participate the end user from the very beginning in what you're doing. And that was nice. And in terms of the app that you're developing for the back, the flexion of the back, for the caregiver, do you think it will help to, based on different movements that each user have, suggest them the exercises that they can do to improve the muscles that they're going to recruit more often, as a feedback to the user? Yeah.
I know that there's a lot of people who talk about strengthening your core and things like that to prevent, prevent injury is what is believed. I don't actually know that there's much evidence that shows that strengthening your core reduces injuries. There's the loads that you're talking about, strengthening the muscles will just result in higher loads, actually, to your spine. The muscles all they're going to do is pull tighter on your trunk and put more load on your spine, right, on your disc.
So for example, those which are designed for the lower back, the one that is like, if you're bending on it.
Yeah. I mean, I don't know whether this is known exactly. My gut says there's, let's see if I can find that picture here. So what I'm saying is the big red arrow, right, is your erector spinae muscles contracting to tighten to support the load of, it's like a teeter-totter where your upper body and whatever you're lifting out here has to be balanced by your erector spinae muscles contracting to balance that. The stronger, strengthening that muscle isn't going to change how much load that disc will see. The only thing that can reduce that is by bringing the load in closer, or by spreading the load out over a greater area, by keeping your facet joints at the back, like I was showing, contacted. But the load on the disc is going to be what it is, and yeah. So I don't. So that's something that I know there's discussion about, and yeah. Other questions? Susan?
Taylor, nice presentation.
Oh, thank
I have
you.
a question about the shoe manufacturers. So when they're designing shoes now, like what factors do they use?
Cost, I think, is a big one. Cost and weight seems to be so. I think all manufacturers recognize that real rubber, will grip things better, but it's heavy and it's more expensive. Everyone's trying to move to plastics and finding different plastic things that can be molded that by their nature just don't stick as well and are lighter. And so it's that I think everyone's trying to push cheaper and cheaper, but find better plastics that will grip better. The way they test it now is with a machine. There's it's called the Satra machine, where they clamp the shoe into the device and slide it across different materials. So you can understand what the coefficient of friction of a different material is going across these materials. We've always sort of questioned the value of that because it's not a very natural movement in any way, right? It doesn't reflect how we walk on surfaces. So that's.
There's a comment in support of what Tilak's saying there. You remember we've had some discussions with some of the insiders in the industry who are engineers who are complaining that in fact engineers don't have any say whatsoever in the design of footwear. It's all done by designers who are graphic designers, and it's done on the basis of appearance, much to their frustration. So there isn't much testing that goes on. When you go and buy a winter shoe, it's generally you're looking for something that has an aggressive-looking tread, an aggressive-looking name, has some right colours and things in it, but it's probably quite useless. It's quite interesting. So we've got to change that culture. We've got to change it by making it so that the labelling becomes so obvious and that consumers become so aware of it that they begin to demand numbers and not just look at appearance.
So I'm wondering how close to commercialization is your support pole, or if you need other in the community testers.
I think Vicky has just wrapped up a round of getting them out into the community to test. So there's a round that's happening right now, and Jeff might be able to say when it's being. I think it's we sort of.
My response to that question is next week.
Yeah.
It's a bit like we'll solve cancer in our lifetime. It's a lovely slogan because you can't disprove it. But it does seem to be very close. I mean, the pole thing that we call it Stand Easy, that we've got some in this hospital to help people get out of bed, is commercially available. And I've seen these poles have been arriving in boxes that are labelled and have pictures on them and stuff of a product. So it's pretty much there. So our answer will be next week, and next week our answer will be next week.
So very close. And, Vicky's in the room. Sorry, I didn't see. I think the first stage will be that it'll be available online from their website, and eventually getting into retailers. Hopefully, that people will see in stores nearby as well.
I have a hunch that it's going to be rent to buy. Because for a lot of people, I think I'm going to be disappointed. I think it's going to be more expensive than I ever hoped for initially, and that realistically that people will hopefully be able to rent it, and the longer they rent it, eventually they'll own it or they'll return it and get recycled, but we'll see. There's some interesting things to be done there. Yeah.
Just following up on this question.
Sure.
Does the base of these movable poles have to be on an extremely flat surface? I'm thinking of bathrooms, for example, that might have the 1 by 1 inch tile laid down. They're not always flat.
Yeah, the base on this is about that big around. So I think 1-inch tiles would be fine. It would cover a number of those. I can't see a problem with that. I think overall you want a level, you need a level ceiling and a level floor. You don't want angled ceilings or anything like that, but I think a little bit of rougher surface is fine, yeah.
I think the next iteration should involve angled ceilings, because a lot of us have angled ceilings upstairs in our homes.
Yeah.
Too bad.
Jeff, I had a question for you because you alluded to cost, and as I've been learning a little bit about this commercialization business, it strikes me that the magic lies in a low cost to produce the device, something with a potentially huge market, and a disposable that people have to keep buying. So that for me is a challenge in terms of having for my own research, a market that's relatively, really very small, probably. Do you see, how do you see our research overcoming those kinds of challenges?
Yeah, cost is a huge issue, isn't it, Tilak? And it's actually not particularly the cost to manufacture that's the issue, it's the cost to distribute. If you buy something that's made for the medical rehabilitation world, it typically costs 1/6 of the retail price that you'll pay. If you can get, at the moment, for example, if you take a product through a retailer, the retailer takes 50 or 60% off the top. So if it's $100 retail, you sell it to the retailer for $40 with the various discounts. If you use a distributor to get it to the retailer, the distributor takes 35% of the $40. So that's a third of the $40, so you're down, 12, 14 down from that, so you're down to $28. And if you've manufactured that, your shareholders and your manufacturing company will want a 60% markup one way or another. So you're now down to $12 to $14 to manufacture it. If you can get it to high enough volumes that you can get it into Walmart or into Home Depot even, but into Walmart instead of through a medical distributor and a medical retailer, then you can get down to 12 to 18% markup overall. And your manufacturing costs come rapidly down because all of a sudden a lot of people buy it. So the key is not actually the cost of making it. The key is somehow getting it into a broader distribution, probably web-based distribution, and getting it out to volumes and having the volumes of people wanting it. And the problem with the aging boom is it hasn't boomed yet. Everyone was thinking that aging boom was about to happen. It's happening now for aging boomers like me, for our mums and dads, actually. And it's going to be happening sooner or later. And so that volume crunch will happen suddenly, and we've got to be ready for that. But it's a lot more complicated than just making it cheaply. How do you get it to the people is the key.
What would you say about strategies where the people who are actually going to have to spend the money to buy a device are not actually the people who are going to save the money downstream that comes from the health, the falls that you've prevented? How do you make those kinds of arguments in the system?
We make those arguments all the time, but the problem is that there's very few people who are actually allowed to move money from one envelope to another, whether it be in government or anywhere else. So it's a very difficult argument to make. People used to say that you'll be saving health costs, but but no one believes that any longer. If you say you'll save beds, it doesn't happen. The beds still get full. With the apnea stuff at the moment, we're making the argument that we can save huge chronic care costs, which, when you think about it, is true. If we diagnose someone with sleep apnea, and they have 4 times the chance of a heart attack, and 4 times the chance of a stroke, and 4 times the chance of causing a car accident, you'd think you'd go out and quickly diagnose and treat everyone, wouldn't you? But the people who are paying for the looking after the strokes and looking after the heart attacks and stuff, first of all, they're going to be out of office within 4 years, and so it's not going to impact their budget. And secondly, they look after the envelope that's just looking after the cost of diagnosis. So these are some of the big challenges we face. And this is why, when you listen to Team Optimize, why we stress so much looking at policy and economic arguments, because we can come up with all the fancy technology in the world, but if people can't afford it, it's actually not going to save money unless we get the policies and the methods to get in there to do it. It's a bit like the transportation problem we have in Toronto. We don't have good subways because we are frightened to tax people and to spend more money when we should have been. And now we're going to suffer because we'll be able to earn less money because we'll have less industry and less business in Toronto eventually, and we'll be poor as a result. So you have to be clear thinking. You've got to have policies that cause investment to happen.
Yeah, I think one other thing is that there needs to be, I think very few people recognize the value of some of these devices that are already out there. Like anyone who has one of these poles, like this is a great video that I've used a number of times. This woman talks about how she was resistant to getting a pole for a long time. Her physiotherapist was telling her, nagging her. Finally, she tried it. Now she loves it and tells everyone she knows that they should get one of these. And my mom has started to do the same thing with her pole. And it's one of, very few people like to think about the fact that they will at one point need these devices, but I think once we start getting more and more people using them and loving them, that I think has a power as well, that eventually the decision makers will have someone they know that has a pole and loves it and says, I want everyone to be able to get one of these. Like that, that's I think part of our role too.
So it's actually 9 minutes past 1. The conversation was so interesting, we're sort of wandering on, and we really shouldn't because we want a good attendance at these meetings. And thank you ever so much for everyone coming, and congratulations, Tilak, on a splendid presentation and all your team. Thank you, Dan.